It went silent first, not all at once, not with a warning. One instrument, then another. 24 billion kilometers from home, a signal that had taken 22.5 hours to arrive on Earth carried nothing but noise. Engineers stared at telemetry that made no sense, numbers that shouldn't exist, patterns that repeated in ways nothing on the spacecraft was designed to produce. For 5 months, the only thing coming back was static dressed up as data. Somewhere out past the edge of the sun's influence, a 46-year-old machine was either dying or it had found something that broke its own instructions. This is the real story of Voyager 1. The Voyager 1 launched on September 5, 1977 from Cape Canaveral, Florida. It was built to last 5 years, enough time to fly past Jupiter and Saturn, take some pictures, and quietly become obsolete. That was 49 years ago. Instead, it kept going, past Saturn's rings, past the orbit of Pluto, past the last measurable trace of the sun's magnetic influence. On August 25, 2012, Voyager 1 became the first human-made object to leave the heliosphere, the bubble of charged particles the sun blows around itself, and enter interstellar space. NASA didn't announce it right away. They spent over a year confirming the data because nobody had ever measured what interstellar space actually looked like up close before, and the readings didn't match any model anyone had built. That should have been the end of the strange part of the story. It wasn't. In 2020, something changed in the data streaming back from Voyager 1's magnetometer, the instrument that measures the strength and direction of magnetic fields around the spacecraft. The readings spiked, abruptly, without warning. At the same time, Voyager's plasma wave instrument recorded a jump in the density of the plasma surrounding it, the thin soup of charged particles that fills the space between stars. Scientists had seen something like this before. Small, temporary jumps, usually tied to solar activity. A burst of particles from the sun would travel outward, slam into the edge of the heliosphere, and send a kind of pressure wave rippling through the interstellar medium beyond it, like dropping a stone into water and watching the ripple spread. Those earlier events always faded. Weeks, sometimes months, and the readings settled back to baseline. This one didn't. The elevated readings held. Then they held longer. Adam Sabo, an astrophysicist at NASA's Goddard Space Flight Center and the principal investigator for Voyager's magnetometer, had a name for what should have been happening. The source is like a piston, Sabo said, describing the mechanism by which solar disturbances compress the plasma at the heliosphere's edge and send the shock wave rolling outward. A piston fires. Then it stops. This one kept firing. By the following year, the anomaly still hadn't faded. And that raised a question mission scientists weren't fully prepared to answer. What if this wasn't coming from the sun at all? Anomaly 2. Voyager 1 is not traveling through empty space. Nothing in the galaxy is. The interstellar medium isn't uniform. It's structured. Clouds and filaments of gas and plasma at different densities drifting through the galaxy at different speeds, some left over from ancient supernova explosions, some just ordinary interstellar gas compressed by forces astronomers are still mapping. One theory, floated by scientists studying the sustained anomaly, was that Voyager 1 might be crossing the boundary of one of these clouds, a region of denser interstellar plasma that had nothing to do with the sun's activity at all. A structure in deep space that no spacecraft had ever physically passed through before, because no spacecraft had ever gotten far enough. If that was true, the sustained magnetic readings weren't an echo of something happening 93 million miles away, back near Earth. They were a direct measurement of the galaxy itself, untouched by the sun, unfiltered by 50 years of assumptions about what interstellar space should look like. 12 billion years. That's roughly the age of some of the oldest structures in the interstellar medium Voyager may be sampling. Material older than the sun, older than Earth, older than anything the spacecraft was ever built to study. And it was reaching the instruments of a probe launched to photograph Saturn's rings. Nobody expected this. Then came the part of the story that made headlines for a very different reason. On November 14, 2023, Voyager 1 stopped making sense. The spacecraft was still there, still receiving commands, still, as far as anyone could tell, physically intact. But everything it sent back was garbled, a repeating pattern with no usable information inside it. Engineers compared it to a dial tone, technically a signal, functionally nothing. For a spacecraft running on computers with 69.63 kilobytes of memory each, less than a single modern text message uses to store an image, there wasn't a lot of room for anything to go wrong. And yet something had. It took until March 2024 for JPL's engineering team to isolate the cause. A single stuck bit in a single chip inside the flight data subsystem, the onboard computer responsible for packaging science and engineering data before transmission home. One bit. Flipped, stuck, or corrupted, possibly by nothing more dramatic than 47 years of wear, or a single high-energy cosmic ray finding its way through the spacecraft's shielding after decades bathed in interstellar radiation. Voyager was never built to survive this long inside. The fix required rewriting the affected code and relocating it to a working section of memory that had enough space to hold it, on a computer built in the 1970s, using tools and documentation that had to be recovered from archives because almost nobody currently at JPL had worked on the original systems. On April 18, 2024, engineers sent the command. Then they waited, 22 and a half hours out, 22 and a half hours back. By the end of this wait, nobody on the Voyager team was pretending they weren't nervous. The following day, the data started making sense again. Meanwhile, back on Earth. While engineers fought to save the spacecraft's telemetry, mission scientists were still trying to understand what Voyager 1 had already told them, the anomaly that started in 2020 and never fully resolved. Bruce Wagner, the Voyager mission assurance manager, described the mood inside the team during the communication blackout as something close to grief. Sad and frustrated to have the spacecraft still working, but muted, Wagner said. Even though we know the end could come at any time, it's never easy to lose a spacecraft. They weren't ready to lose it, not with a mystery still open. Each of the twin Voyager spacecraft loses roughly 4 watts of electrical power every year, as the plutonium powering their radioisotope generators steadily decays. Engineers have spent years switching off subsystems and heaters to conserve what's left, rationing power like a submarine crew rationing oxygen, deciding which instruments live and which go dark, one at a time, permanently. No science instrument had been deliberately shut down because of the anomaly itself. But the clock on the whole mission was already running out, independent of any glitch. Sometime in the next few years, there won't be enough power left to run anything at all, which meant the team wasn't just troubleshooting a computer. They were racing to understand a 46-year-old anomaly in a spacecraft with a battery that cannot be recharged before the last watt of power ran out and the question became permanently unanswerable. The second sign. When the data resumed in 2024, the sustained magnetic field elevation was still there, still holding, still not fading the way the older, sun-driven disturbances always had. Some researchers pointed to this as tentative support for the interstellar cloud theory, that Voyager 1 might genuinely be sampling a structure in the galaxy that Earth-based instruments have no way of directly measuring, because nothing built by humans had ever traveled far enough to reach it before. If that holds up, it would mean the boundary of the solar system isn't a clean line where the sun's influence simply stops. It would mean interstellar space itself has texture, regions denser and thinner, older and younger, arranged in ways that shape what any future spacecraft or any future signal will encounter out there. That is the kind of finding that rewrites textbooks. Carefully, slowly. Not with a headline, but with years of committee reviews, peer analysis, and instruments that have to keep working long enough to gather more than a single data point. The rebuttal. Here's the part responsible reporting on this story tends to skip. NASA has not confirmed that Voyager 1 crossed into an alien plasma cloud. What NASA has confirmed is that the magnetic field readings have stayed elevated longer than earlier, solar-driven anomalies did, and that scientists don't yet have a fully settled explanation for why. Those are two very different sentences. Adam Shabo's piston mechanism, solar-driven pressure waves compressing the interstellar plasma from millions of miles away,